Good morning. I posted a video yesterday answering a question about how to take the negation of a conditional statement. And I got a few follow-ups from that one regarding negations of other types of compound statements, namely ands and ors. So today we're going to be taking a look at how we can take the negation of an and statement, how we can take the negation of an or statement. Now, to do this, we're going to be using what's known as De Morgan's laws. And you may be familiar with this first from a discussion of set theory. And so let's see if we can take a quick recap on how De Morgan's laws applied to sets, intersections, unions, complements, because it's going to be fairly similar when it comes to logic and statements and negations, etc. as well. So if you remember back to your set theory discussion, or if you've seen set theory before, you'll know that for sets A and B, it's equivalent to say that the complement of an intersection is the union of the complements. So A intersect B complement is equal to A complement union B complement. And this is also true in reverse as well. If we are taking the complement of a union, that's going to be the intersection of the complements. And so in some sense, we can apply this complement symbol or this complement operation to each of the individual terms in parentheses as long as we switch the intersection to a union and the union to the intersection. Now, what you want to notice here, and if you've studied logic and set theory for a little while, there's a lot of similarities. In fact, in some sense, they are pretty analogous to each other. And so we can look at something like a complement of a set and compare that to a negation of a statement, right? And these two are sort of analogous ideas, right? Because the complement is saying take everything that is not in our set, and the negation is literally saying not our statement. So these are similar ideas. Likewise, the intersection of two sets is analogous to the idea of an and statement, right? And when we first learn about intersections, we emphasize the idea that it is related to the word and, as in to belong to the intersection of A and B, you have to belong to A and belong to B. And that's going to be similar with statements as well, right? For an and statement to be true, both of the two compound statements have to be true. And so there's a really nice analogy between intersections and ands. And if you can kind of guess the pattern of where this is going, well, also we can say that unions are analogous to or statements. Because when you take the union, you're talking about all of the elements that belong to set A or set B. And when you take an or statement, that can be true when either the first statement or the second statement is true. And so keeping this in mind, that all of these are analogous, is going to allow us to take this same idea of De Morgan's laws, but apply it to set theory. And so to rewrite this in terms of logic, rather than using complements and intersections and unions, here we'll say that for two statements, so for statements P and Q, the negation of an and statement, so negating this compound P and Q, is going to be the same as the negation of P or the negation of Q. And likewise, if we take the negation of an or statement, that's going to be the negation of P and the negation of Q. Right, and so we have this same sort of idea. We can apply the negation to each of the individual simple statements as long as we flip the direction of the sign. And so if we take a look at how that applies to an example, let's consider we have a statement that says something like, the sun is out and the sky is blue. If we want to find the negation of this, we can take advantage of De Morgan's laws to do that, right? Because this is a compound statement. We have the sun is out, which maybe we'll call P, and the sky is blue, which maybe we'll call Q. And so we have the statement P and Q. And we want to take the negation of this. And if we use De Morgan's laws, we can apply the negation to each of the individual statements as long as we flip the and to an or. And so our final statement would be not P or not Q. Now, translating that back to English, not P would mean the sun is not out, or, because now we have to flip the and to an or, not Q, which would be the sky is not blue. And this would be our final answer for the negation. Awesome. I hope you found that helpful. Thank you for submitting the follow-up questions. I will put a little card in the top right-hand corner if you are curious about the previous video, how to negate a conditional statement. But otherwise, thank you guys for watching. Keep submitting your questions below and have a great day.